everyone. Good morning, and thank you so much for joining us today for our webinar on unlocking the future of on-demand VR streaming. Just a couple of housekeeping notes to start first before I introduce our speakers today and then hand the mic over to them. This is being recorded, so we will be sharing this recording after the fact. In addition to that, if anyone has any questions that come up during the presentation, feel free to throw your question into the Q&A that you'll see at the bottom of your screen, and we will answer the questions at the end of the presentation. Other than that, nothing, those are kind of the two main housekeeping notes there. I'm happy to introduce today our speakers. We have Chris Jarabek, who is our head of product development, as well as Kevin Viggers, who is our head of R&D. And we'll also be having Terry Westlack, who will be working, running the demo of the new on-demand CloudXR VR streaming support alongside Chris. So at this point, I'll hand it over to Chris. And thank you everyone again for joining.
All right, thanks very much, Candy. I assume everybody can see the slides here. The agenda for today looks as thus. We're going to talk a little bit about who we are as PureWeb, what it is we've been doing sort of historically in the streaming space, and really the sort of the bulk of the talk is going to be around what we've learned as we've added VR streaming support through CloudXR to our cloud platform. And we're going to run through a demo, obviously this, sort of show how easy it is and what that could look like in sort of a practical application. And then we're going to talk a little bit about how we implemented our solution of CloudXR under the hood, and then a little bit of a discussion about where we're going to be going next in terms of the future. And in terms of the future, this is really how we see things here at PureWeb. We are really focused on creating a world where immersive experiences are seamlessly integrated into everybody's life in a way that is both positive and really evolves the interactions that people have with everyday, both digital experiences and other people. The key word here, and the one that's going to sort of be a thread through this talk, is this idea of seamlessness. Really what we have is this this position that we're at right now where we're starting to see more and more capable headsets come onto the market, but they all have these sort of drawbacks. And to really have immersive experiences be seamless, we think having a form factor that is more akin to the glasses that I'm wearing as opposed to a large headset is going to be the way to get there. And so really we see CloudXR and VR streaming in general as a crucial stepping stone towards getting towards that more seamless immersive experience. So with that, who we are at PureWeb is we have built a global platform that essentially connects users around the world to immersive experiences. So really, if you have any internet-connected device, whether it's a web browser or a headset, you can have immersive experiences, high-fidelity immersive experiences available on those devices at scale instantly. And the way in which we do this is through remote streaming. I won't assume that everybody on this call knows what that is, so I'll talk about it a little bit in detail here. Remote streaming is essentially this idea where rather than running all of the heavy graphical compute on your local device, you're instead running that compute on a remote server somewhere, typically in a cloud or in an on-premise data center, and you capture the rendered output of that application, and you stream that video down to the end device, whether it's a browser, tablet, laptop, or a headset, and then you capture the inputs from that headset. So it could be motion tracking for hands if you're looking at a headset, or it could be taps if you're using a mobile device. And those are sent back to the remote server. And so you end up with this perpetual loop of inputs coming from the device and video being streamed down to the device. And this creates the very real impression that you're interacting with this rich, high-fidelity experience on this generally low-powered device. And I think remote streaming is really interesting from that sort of seamlessness perspective, because when you have a really capable device, it's going to have some inherent drawbacks. I list some of them out here. You're going to have things that are big. You're going to have things that are heavy, hot, tethered, and expensive. And if we zero in specifically on the headset market, I think it's quite interesting because the Apple Vision Pro is very much on everyone's minds right now, and it gives us a very interesting glimpse into what a very capable all-in-one headset device might look like. But we also know that the Apple Vision Pro also ticks a lot of these boxes. It is heavy, it is hot, it's tethered, albeit to a battery pack, and it is very expensive. But it gives us a glimpse of like what the immersive experience could look like. So now how do we solve for that seamless component? And I think that's where remote streaming plays an interesting role. It sort of breaks that symmetry between the capability of the device and the form factor of the device. So at PureWeb Reality, we have been supporting remote streaming protocols at scale for several years. So we started development on the Reality platform back in 2014. This was an R&D project, and we started building out on AWS at the time. And really, we were focusing on streaming to the browser as the end device. And what was interesting at this time was we were working with customers who were Unreal and Unity customers, and they wanted a way to have their experiences made broadly available to users no matter where they were. And what's interesting here was that we saw a very clear need, particularly in the enterprise market segment, because when people were building Unreal and Unity applications for gamers, you could reasonably assume that the gamers that you were building for had gaming PCs or otherwise would have the hardware necessary to run these rich immersive experiences. But when you started working with these enterprise companies, that was no longer a safe assumption. A lot of these businesses are not going to put gaming PCs on everyone's desk, or if they're building a B2C solution, they can't assume that all of their users are going to have the graphical power necessary on their devices to run these experiences. And so this is where we start to see this fairly significant influx of users who wanted this sort of remote streaming solution. And that essentially allowed them to have the broader reach that they were looking for. Now, at the time, there wasn't actually a way of streaming Unreal and Unity to the web browser. So we actually built our own protocol back in 2016 to solve for this problem. And then a couple of years later, 2018, 2019, Unreal and Unity both introduced their in-engine streaming protocol. And this was a huge relief to us because it meant that we no longer had to maintain our own proprietary protocol and we could meet Unreal and Unity developers where they were. And so that was a huge relief and really an unlock because it also suggested that real-time streaming was something that the industry was taking very seriously. And then so we fast forward through into the commercialization phase, and around about 2022 is when we really start to see traction with this idea of virtual reality streaming. CloudXR had been on the scene for 6-7 months, and we thought it was about time to start looking at what it would look like if we added that as a novel streaming protocol onto our platform. And then, as we sort of fast forward into the current day, we're, looking past CloudXR to other immersive streaming protocols and other types of workloads that are sort of compute intensive that could run in this environment as well. And yeah, I think in terms of timeline, that's sort of the history of where we're at. Talking a little bit about the use cases for this. Again, I've really keyed in on the idea of enterprise use cases for this technology. So the principal ones that we see, and this is borrowing both from VR customers that we're working with, and as well as, or I should say, CloudXR customers that we're working with, as well as traditional browser-based streaming. These are industries that many of you are probably familiar with. So architecture, construction, and real estate is a significant one, probably our largest. Though I would say that with the advent of VR streaming, training and simulation or training and simulation and education are really very prominent use cases in the VR space. And then digital twins and product configurators also very common. So these are situations where you want to have really high fidelity or very data intensive immersive experiences that you just could never run on a phone or a tablet or a low powered laptop. And so remote streaming is a fantastic solution for that. So that is sort of the history of where we are. I'm going to shift gears a little bit. I'm going to hand the mic over to Kevin, and we're going to talk a little bit about our journey with CloudXR. So really how we started working with technology, where we are today, and what we learned along the way. Kevin?
All right, thanks, Chris. Hello, everyone. Yeah, as Chris said, we started exploring CloudXR in 2022. It really began with the development of a prototype on top of our platform, supporting the CloudXR protocol. And we went out and we wanted to validate this prototype with our customers and our partners and anyone who would really just take a look at it. And so we spoke with people who were doing large facility visualizations, architectural walkthroughs, training situations, and also even people designing amusement parks and playgrounds. We spoke with a as diverse a group as we could to really glean some insights on what this could do for them and what it meant to us. So one of the first discoveries that we did come across was that, sorry, Chris, yeah, thanks. People are super excited about headsets and streaming to XR devices in general, but there was pretty widespread acknowledgement that these experiences won't exist in isolation. People are looking for an ubiquitous solution that can reach as many of their customers in as many contexts as possible. So I mean, it was expressed to us that while there was a lot of excitement streaming to the headsets, things like pixel streaming are not going away. In fact, people wanted to have a way to gracefully fall back to pixel streaming when users were not able to access a headset at all, but they did have browsers or phones in their hands. Second thing that we wanted to talk about was around the use cases themselves and how XR experiences don't really sit in isolation, but the experiences that people are trying to create are tied to accelerated services like AI services or recommender services. So we, in this context, in particular, we had one training scenario where technicians were placed in subterranean environments to repair equipment underneath the streets. And so there's a lot of vision and recommendation services that were tied to this experience. That locality is super important for a fast and responsive experience. So it wasn't simply that they were experiencing XR or in isolation, but they needed these services to be close to the compute. And that's something that streaming excels at, as it puts the resources that you need for that in the right place. Maybe the third thing that really struck us, and it makes a lot of sense. I mean, when you look at the resources available on the headset, as Chris said, they're limited, but they have their strengths as well. And when you look at what you can do on the remote side, there is a balance to be struck along this spectrum. Things like those vision problems, or those recommendation problems that need the acceleration on the server side, that's where they belong. Things like UI and local gestures, those excel on the local side. So there's a balance to be struck there. And I mean, I don't think there's a solution that is out there right now that fully satisfies this balance. And it's going to depend on the context in which your application, your experience that you're trying to create is going for. But so this is a bit of an open question right now. I mean, split rendering, all these types of things are coming along, but so we've got a keen eye on what's coming next here and what we can do to find the balance here. Chris?
Thanks very much. So before we do a demo, we'll just sort of give a little high-level overview of how sort of PureWeb works, and then we'll jump into the demo and then talk a little bit about the underlying implementation. So at PureWeb, we really see ourselves as being the connective fabric between the people who are building graphically intensive workloads, whether it's with Unreal or Unity or just native OpenXR compatible applications for CloudXR, the audiences they want to reach, whether those audiences are running on mobile devices or headsets or laptops, and then the infrastructure that's necessary to power these accelerated compute, these experiences. So right now we operate across AWS and a little bit on CoreWeave. And so really we want to be sort of trying to smooth the management of that infrastructure, because managing that infrastructure at scale and the edge orchestration challenges are not trivial. And so really, we want to make it as simple as possible. Drag and drop your application, which is what we're going to show. We take care of all the automated deployment, the plug and play runtime environments, so that our application, your applications are inherently compatible with our environments. And then we want to make the client experience as easy as possible. So that's by providing a wide variety of client access methods, both for browser and for headset. And then also solving all the problems around things like network traversal and making sure that you have excellent connectivity from the end user device to our platform. So with that, we're going to jump into a demo. I'm going to pause just for a quick second here and just remind everyone that if you do have questions, please just pop them into the question channel. We have seen a few questions show up so far, and we'll address those at the end. So onwards to the demo. So what we're going to do here is, if you can still see, can you see my browser window now? And I'm going to pop over to the PureWeb console. So this is the home base for PureWeb. And essentially, it's where all of your immersive models are stored on our platform. So I've already logged in here to this account. We have a wide variety of projects in this particular account. And we can see there's a couple of models already present here. And this is where we're going to go and upload our CloudXR application. So what I'm going to do here, just open up the new model. I'm going to drag and drop an application from my desktop into the console here. And we do a few checks to make sure that this looks like what we'd expect for a Unity application. In this case, where I'm uploading the Unity client template, or probably the Unity VR template. So we've intentionally chosen a very small application so that we don't all have to sit here watching me upload a 5 GB application. Nobody would enjoy that. This is a much smaller application. And so what we're going to do here is we're just going to click upload, and it's going to start uploading to our platform. And once that has happened, it's immediately going to start fanning out to what we refer to as our virtualization providers around the world. And we have several dozen of these globally. And you can see right now, here's the model. It was a CXR demo. And right now it shows as unavailable. And that basically says our platform has received the model, but it doesn't know of anywhere within our platform infrastructure providers that can currently run that model. And so that's just because the model is actively being provisioned out. And what we're going to see here is that this is going to flip from unavailable to available in probably a few seconds here. And that is essentially our platform saying, yes, one of these providers has checked in and has said that, yes, in fact, this model is ready to stream. And that should happen in just a moment here. And just going to give us a quick refresh. Pardon me. I apologize. I'm going to just do that one more time here. Oh, and there I was. I was just not patient enough. It just took a few extra seconds this time. My apologies. So we see the model went available. So that was essentially our platform saying, yes, one of these providers is now checked in. We'll have another one going in the background. It won't do any harm. And yeah, so with that, I'm going to actually hand it over to Terry. Terry's got the headset, and he's going to walk us through the rest of the experience from the consumer side, the client side. Terry, I'm going to stop sharing my screen now, and you can take over.
Great, thanks, Chris. First of all, can you guys hear me?
Yeah, I can hear you.
Okay, just want to confirm one fun thing with the headset is it constantly changes my audio settings back and forth. So just wanted to make sure you can hear me. So I'm going to share up my screen here. And basically what you guys are going to see, I've got basically a Meta Quest 3 headset here. I'm not sure how easy this is going to be able to see on the camera. And I'm casting it to, can you guys see my screen here?
Yep.
Okay, so I'm casting this to basically the Meta website, so you guys can see what I'm seeing from the headset. So I'm going to just jump into the experience here, and I'm going to walk you through just the CXR demo here, running live on our platform. So on the headset, we have a client that's actually set up. I'm going to go launch this client. the client at this point is going to go talk to our platform, and it's going to go look basically at that list of models that Chris has set up there in the same project, and it's going to get a list of what it can actually run. So as you can see here, here's the CXR demo that Chris just uploaded, including the CXR demo 2 as well, and the other models that we have here. So I'm going to go and select this model, and then when I do that, that's going to basically place a request to our platform to say, hey, I want to go actually run this model. Our routing system will then go and figure out where in the world there's servers that can run this. It'll go tell that server to basically launch this model, and when the model launches, it's going to connect back to the headset. So as you can see, I'm literally already into the game that Chris had just uploaded a couple minutes ago. So as Chris said, this is the Unity template model. It's just running on Unity Engine 2023. One thing to note, because I'm casting this to basically Meta's website and then resharing that across Zoom, the performance that you're seeing is not going to be quite the same performance that I'm seeing. So I'm seeing about 70 frames per second, but what you guys are going to see is just the cast single image eye that's coming back from there. So now that I'm in the game, I'll just kind of do a quick little run through here. Just like any other VR project that's basically OpenXR compatible, we can go and do and stream anything that's available here. So as you can see, I've got controllers in hand. I can actually move those around. Those have buttons that can interact with different things. There's some menus that we have set up in the model here that's just by default, and you can actually go and interact with these objects in the game. You can move stuff around. You can even, and this is kind of typical for VR, you can kind of teleport to wherever you want to go and look at. And you also have a movement control, so you can actually go and move as if you were kind of walking around. We have different objects in the scene here that we can go and kind of play with. Here's one, this one can show you, this is like a good point to show you can have multiple different things with the controller going at once. So I've got an object that I'm holding, that I'm moving, and I'm triggering all at the same time. The one thing you guys don't get to see, or I should say hear, is basically like the sound effects and the audio that's in the game. So anything the game has set up for sound, like when I basically go over menus, I can hear different clicking sounds, and if there's like background music or ambient noises, those will also be playing as well. So in the model, this is basically our CXR demo. This is basically running on a server that's about, it's about 1,000 miles away from me, about 1,600 kilometers away. And what you guys kind of can't see is basically just the general performance. Like I said, I'm getting about 72 frames per second right now. And this is basically our demo. So one thing I want to highlight, again, with Chris basically uploading this, is Chris uploaded this, and within about 2 minutes, I was up and running with a cloud stream. And the nice thing is, for like end users, once this model has actually gone available, that's available for anyone out there that has an internet connection and a headset that's capable of connecting. So with that, basically, I'm just going to pass this back to Chris, and I'll stop sharing here.
Thanks very much, Terry. So I'm going to talk a little bit about sort of the implementation of how we achieve the demo that Terry walked us through right now, and I'm going to call back to a number of the points that Terry mentioned in the demo itself. And so I'm just going to go back here, and I'm going to reshare my screen here. Just a moment. Okay. And can everybody see my screen again?
Yep.
All right, thanks, Terry. All right, so in terms of the underlying implementation, so this is the sort of 10,000 foot view of the Pure platform. It essentially architectural diagram. So what we're talking about here is there's a sort of a partition in our platform between what we refer to as our core platform and then what we refer to as our virtualization providers. You may have heard me use that term a little bit earlier. The core platform runs on AWS, and it handles things like identity and authentication. Critically, it handles the global routing system. Terry mentioned it briefly, and it kind of happened in a bit of a flash there, but it's one of the really critical points, particularly for VR streaming. So I want to dive into that one a little bit. So essentially, we have all this infrastructure that runs across multiple clouds. all over the world. And those different providers have different characteristics in terms of the infrastructure they run, the models that are certainly currently can be run on those types of infrastructure, and the utilization levels of that infrastructure at any given point in time, because there's always ebbs and flows in traffic on our platform. So the global routing system is constantly getting live feeds of information from all these different global providers, and it's being fed into our global routing system. And essentially, we're making a choice in sort of a very just-in-time fashion to figure out where is the very best place that we can send you to have the very best stream possible. And for us, very best essentially is a balance between you don't have to wait at all and you have extremely low latency, because all this is happening over a network, minimizing that latency is as critical as possible. So we take all these variables and we put it into the hopper, and then when you saw Terry fire off the client connection in the headset, there was basically a check within our platform that said, yes, this server that was about 1,000 kilometers away is the best place for you to run this application right now. And it was running in one of our on-demand pools. And we'll talk a little bit more about this as we go on here. So that's the global routing system. Model storage, obviously, we have to store these 3D models. And then we also have things like our signaling and matchmaking. So it was fully transparent in that workflow that Terry demonstrated, but essentially we host a collection of services that make sure that we can broker that handshaking connection so that it is as easy as clicking a button and then you just get a stream. You don't have to do things like configure the IP address of the host machine that you're connecting into. So that's the core platform. And then we have these ideas that we call these virtualization providers. We have two classes of virtualization providers, but we had historically 3 implementations, and now we have 4. I'll talk a bit more about that. We have 2 types of virtualization providers that run on AWS. One is what we refer to as a dedicated provider. So this is where we have the ability to stand up any type of bespoke custom infrastructure to any project for any customer anywhere in the world. So AWS is expansive. We can use any type of infrastructure they have and attach it to your project to support your streaming needs. So this is essentially if you want custom scaling behavior, custom GPUs, custom or particularly high scale capacity. So if we're talking thousands, tens of thousands of users, that's the option that we always recommend. But then we also maintain what we refer to as our on-demand providers. And so this is where you might not have predictability in your usage patterns, and where you would actually have, basically you just want to pull on an existing pool of servers. And so we maintain 8 of these on-demand pools globally. We have a number of pools that run in AWS, and we have a couple of pools that run in CoreWeave. And essentially when you use an on-demand session, and what we saw in the demo just now was from an on-demand pool, our platform pulls a fresh, clean server from this pool that's ready to go. It provisions the model out of a cache or from storage if necessary, and then it actually launches the stream. So in that situation, there's no customizations, just these pools are readily available to everybody who's using our on-demand solution. So that's the solution at the high level. And then in terms of how we took that and evolved it to where we are today with CloudXR, the first thing we really needed to do was give the backend infrastructure a boost. So when we're dealing with pixel streaming to the browser, you're dealing with a single visual pane, and that might be up to 4K, but that's still a considerably less demanding compute workload than a binocular experience where you have to effectively render 2 viewports at the same time and stream that down. And the latency expectations around VR are also quite a bit more severe, because if you have significant or meaningful latency, both either in the rendering or in the network piece, then you get very negative side effects like motion sickness. And so this is where we really wanted to make sure that we had GPU capabilities that would get the best frame rate at the source, and then we could place those users as close to those GPUs as possible with our global routing system. So going back to this infrastructure diagram for a quick second, the very first thing we did was we looked at our infrastructure providers and we said, what's the best GPU we can get access to right now? And for us, that was the A6000 in CoreWeave. Though I will say that with the L40S coming online in AWS in the coming, realistically, weeks here, we're very excited to actually add that into the stable as well. And I think that'll be a fantastic option for CloudXR. So what we did was we actually added a new on-demand provider type. This was what we refer to as our high-performance CoreWeave provider type. It was based around the A6000, and this was extremely well suited to running these VR workloads. That was all relatively straightforward. This was a couple of weeks of effort on our team to make this change. The more sticky stuff was when we get into some of the CloudXR complexities. So the client workflow piece was the next challenge that we had to solve. And this was really born out of the conversations that Kevin mentioned earlier. We talked to these different customers about what they wanted from a client workflow. There are really two narratives that we saw. One was, I want something that is like ready to go, easy to use, and requires minimal configuration. And so for that, we've gone down this path of creating what we refer to as our preview client. And the preview client is what Terry demonstrated in his demo earlier. So this is where we have a pre-baked client that is wrapping our platform SDK, and it's configured with some very simple authentication details. So if you recall, Terry clicked the button and brought up the Unity client. From there, he saw a list of the models that were available in his project. So the configuration that was done in advance, which we just didn't show, is that the client was given the authentication details and the project information so that it could connect into that project and see the list of models. And it's done that through our platform API. From there, he launches an application and we get a stream and everything is running smoothly. That is a really excellent way of sort of starting your CloudXR journey, but the use cases that we're really hearing from people who are thinking more in a longer term production mindset was that there was some customization that was really needed. And so this is where we've gone down this path of creating out a client template. So rather than producing a ready-to-use, basically deployable application, we're essentially producing a code template so that our customers, if they have an internal development team, they can customize that however they want. So the two big factors, what you might want to do is for branding. So if you want to have a custom branded client experience, that's a fantastic way of doing it. And then if you want to wire into external services, so external authentication services, or really any sort of API-powered service, you could do that through essentially a custom client. We don't have any sort of opinions on that. We're very agnostic to what sort of services you can integrate with. We just want to provide a client that's ready to sort of bootstrap with the necessary streaming pieces. At the end of the day, it's still using the same underlying SDK to talk to the same platform API. And so that sort of represents a journey from sort of maybe a sort of a POC initial development phase with the preview client to a more production-oriented mindset with the customized client. And then the last real complexity in all of this was around signaling, sequencing, and Steam VR. And for anybody who has worked with CloudXR in the past, you probably know that this is a little bit of a hairy problem. And so to illuminate it a little bit better, I'm going to talk about the way signaling and sequencing works for a pixel streaming application or a browser streaming application, in other words, and then we'll contrast that with what it looks like in a CloudXR application. So if you were launching a 2D experience from a web browser to our platform, you're going to start with a browser launch. You're going to talk to our platform API. This is brokered through our SDK, but it's still talking to the API. And what's going to happen is the browser is going to enter into what we call a signaling environment. And basically, this is where it is going to essentially meet with its streaming peer to coordinate information about setting up a stream. The platform is going to talk to a lifecycle service in one of those virtualization providers, and it's going to say, this particular model has been requested, please start it up and go and meet the client in this particular signaling environment. So the lifecycle service starts up the 3D model. This would be your Unity application or your Unreal application. It's going to start up through the sidecar signaling process, which is going to talk back into the signaling environment. And at that point, the application and the client can exchange information and negotiate a WebRTC stream. So exchange ICE candidates and basically settle on a candidate pair, and then you have a stream negotiated. And that's really it. So very straightforward in the browser streaming scenario. When you do this in a headset streaming scenario, it is meaningfully more complicated. So you start with a headset launch. It starts to look very similar. You're going to talk to the platform API, and the headset is going to join into that signaling environment. But for anybody who's worked with CloudXR, you know that currently there is this dependency that the server has to run SteamVR. And so there's this chicken and egg problem that the headset needs to know the IP address of the server that it's going to connect to. And when you're in an on-demand environment, like we've demonstrated, you don't know where that server is or how it's been configured. It's being plucked from a pool and provisioned, and then it's going to connect in. So there's this complexity around how you do that sequencing to make sure that it can connect to the right server. So at the end of the day, the platform is still going to talk to a lifecycle service. And the first thing it's going to do is going to find a candidate server that can run the application. It's going to fire up a signaling process, again, like before, and it's going to fire back into the signaling environment. It's going to say, this is the IP address of the public server, or basically the public IP address, pardon me, and the server that you can connect to, headset. And so once it's done that, the headset knows the SteamVR endpoint that it's going to be talking to. So from there, we can finally start up SteamVR, and we have to start up the sort of a log monitoring process so that we can actually verify that SteamVR is up and running and happy. Anybody who's worked with SteamVR probably knows that it is not the most stable piece of software to ever been written, but by sort of looking for key messages in the log files, you can actually confirm to yourself that it is in fact happy and in a stable state and ready to accept a CloudXR connection. And so once that's happened, then you know you can finally connect in your headset into SteamVR. And once we've seen the signal for that, then you can finally start your 3D model. And at that point, you've closed the loop and you actually have a CloudXR stream going on. So as you can see, this is meaningfully more complex than it is in a browser streaming world. And I think this is all sort of a very good illustration of how we're very excited to work with NVIDIA as they work to actually eliminate the dependency on SteamVR. So we know this is a roadmap item for them, and it's something that we're very excited to adopt internally because that will meaningfully simplify this and basically make the whole solution more scalable. So that is, at a high level, really the work that was done to bring CloudXR to our platform. We're going to talk a little bit about sort of the future-facing work now. So in terms of what's next, the first one I can speak to a little bit, which is that, as I said, SteamVR is going to be going away. It's got a target on its back, and we know that there's going to be an OpenXR native runtime that is going to be coming along. This is not something that we want our customers to care about, but it's certainly something that we care about because it makes the solution just considerably more easy to manage and sustainable in the long run. And then the experience that we demonstrated from the client side of things, it uses part of NVIDIA's Unity client, but it doesn't use all of their Unity client. We have found places where their legacy, excuse me, Java client does perform meaningfully better. And so we are really working with the NVIDIA team to identify areas for performance improvement in their Unity client and get those into our hands as quickly as possible. So these are very tactical, sort of product-focused things. But when we think about some of the longer-term things, I'll just hand it over to Kevin, and you can talk maybe a little bit about some of the more future-facing elements.
Yeah, thanks, Chris. I mean, we talked about ubiquity and reach briefly, how customers might want to both deliver a CloudXR experience to those who can receive it, but also have a way for a broader audience to experience that through pixel streaming and other protocols as well. So, I mean, work towards building out a solution that properly captures those hybrid experiences is something that we're actively looking at. Beyond that, I mean, there are a number of ways we can build out our platform to accelerate the experiences and bring in services and like artificial intelligence that will really change the game. So we started with AWS and game engine streaming engines like Unreal and render streaming. We've moved to CoreWeave on the virtualization side to support on demand and reach a broader audience. We've talked today about VR streaming and introducing that protocol, but beyond that, we want to look at other immersive protocols that are starting to emerge, things like split rendering and I mean, there's a number of vendors who are building out their own protocols to achieve immersive experiences. We want to take a look at running, in general, non-visual workloads that support visual experiences, but also augment sort of persisted virtual environments in other ways. Lots to work towards. It's an open world here for us to explore.
Excellent. And with that, I think we're at the end here. So if you want to sign up to essentially get early access, so we're currently in a closed beta phase with this, but we'll be moving to GA realistically in the next several weeks here. And so if you want to sign up, you can either fire on the QR code there, or there is a sign up page in the Get in Touch section, or you can always just reach out to sales@pureweb.com, and our account executive team would be very happy to talk to you. And myself or Kevin might also learn to join you and learn a little bit more about your use case as well. But with that, I see there's been a number of questions that have come in from the audience here. So we're going to just fire through a few of these here. Briam is asking, is hand tracking supported? So currently hand tracking is not supported. This is functionally part of CloudXR. So essentially what we're doing is taking CloudXR and making it scalable and easy to use. And so the capabilities that are baked into CloudXR are what we essentially have to work with out of the gate. Now, Kevin and I were at GTC last month, and we participated in the CloudXR roundtable with a number of other industry partners in the NVIDIA CloudXR team. And they did say that hand tracking is on the roadmap. They have said that it's likely going to be landing in something like CloudXR 5.0, and they don't have a firm timeline for when that will be, but it is very much on their radar. Let's see here. Next, we have, what sort of bandwidth and latencies are needed to support the VR streaming from the cloud? So I sort of alluded to this a little bit earlier with the sort of the fact that VR streaming is a little bit more sensitive to network conditions. So a few things. I mean, the bandwidth and latency is really going to, again, it boils down to what is in CloudXR. So their recommendation is 50 megabits per second, but their preference is 100 megabits per second in terms of network bandwidth. And excuse me, and that is we've seen that in practice where actually the 50 megabit is generally about right. I mean, you can push that a little bit lower, maybe like 40 megabits, and still have a pretty good experience. And then really anything honestly above 60 megabits per second is excellent. So that's on the bandwidth side. On the latency side, we've really noticed there's sort of a few buckets. So anything sub 30 milliseconds is tremendous. It works extremely well. It's seamless. It's like you're running the device. You know, as an example, like Terry in the demo showed the Unity VR client. But internally during testing, because it's a really heavy application, we were actually testing with Half-Life Alyx. It's not a commercial application, but it's really a very impressive VR application. And, you know, when we were running in environments where we were getting sort of sub 30 milliseconds, it was like you're running natively on the device and you had a RTX 4080 sitting next to you. It was tremendous. From about 30 to about 60 milliseconds, it's generally quite usable. So you might notice the occasional hiccup. I would say, yeah, very, very usable. We used it in that latency range, and it hasn't caused any issues for me. I'm particularly sensitive to motion sickness in VR environments, and I didn't experience it any more than I normally would in a local tethered environment. And then really past sort of like 55, 60 milliseconds is where you start to see meaningful degradation. And so that's where sort of we try to take that global routing problem and put that into the mix to try and move you as close as possible to that infrastructure. We have here one around, do we support the Apple Vision Pro? Kevin, do you want to speak to that one maybe a little bit?
Sure, yeah. Short answer is not yet, I guess is the best way to say it. And again, this comes down to where NVIDIA is at in their support for the Apple Vision Pro today with CloudXR. It's definitely something they've talked about. They've announced that support in terms of the Omniverse work that they're doing at GTC. So it's just a matter of time at this point. Unfortunately, we don't have hard and fast dates that we can talk to just yet there.
Next we have, can we integrate with our Microsoft Power Platform? So I would say the question there is very likely yes. So there's a couple of different integration points. With Microsoft Power Platform, I'm assuming it's sort of like you want to use it as this sort of like central home for sort of your access to these sorts of systems. Our platform has a full API and an SDK that you can integrate with. And so if there's an API connection point with Microsoft Power, that should be the case. If you wanted to integrate anything from the Microsoft Power platform that is sort of from their API side into the client experience, you could do that with a custom client as well. But again, this is all going to be sort of custom code. It's not going to be ready to go integration with Microsoft Power. Can you go into more detail about the private, Daniel asks, could you go into more detail about the private infra option, how high on this is in your agenda? That's to say estimated time of arrival. How would this work in practice? And it says, I guess the workload would be routed to my local infrastructure. So yeah, absolutely. So as we talked about, right now we're running on public cloud infrastructure, with the majority of that being AWS, and then some select workloads on CoreWeave. And then essentially the architecture, as we sort of described it out, we have the ability to have these different types of virtualization providers. There's no reason we couldn't have a virtualization provider that runs on any other public cloud. The challenge around private cloud infrastructure or private infrastructure is that when we talk to customers who are interested in basically a bring your own infrastructure model, the principal reason for that is around data security. It's around, we never want our model to leave our network perimeter at all. And so the way in which that would functionally work, and this is the way we're sort of talking about it internally, is that there would be essentially some infrastructure templates that we would provide to our customers, and that would allow you to stand up your infrastructure and connect it into our platform. Essentially, what that would mean in practice is that you would have to essentially configure your models on the back end. So our platform would essentially say, hey, I know about this model. I don't have access to it, but I know that it runs in this customer's private infrastructure. I know that only their users can have access to it. At the end of the day, it would functionally be the same thing. It would go through a global routing system, but it would take a bit of a shortcut and say, oh, well, this is a private infrastructure option. It should only be available to these users, and it should only be for these models, and we'll just bypass it and go directly to your infrastructure and then launch the same application. So this is still a roadmap item right now. We've talked about it sort of in a design context, but realistically, this is not something we could see delivering in 2024, but it's very reasonably something that we would see delivering in 2025. And if that's something you're interested in please feel free to reach out, and we'd be more than happy to both understand your use case a little bit more and work with you potentially if this is something you'd want to see. Because the more customers who want this sort of stuff, the more priority it gets on the roadmap as well. Renee asks, is CloudXR multi-user capable? So yes, I would say that the way in which we have seen multi-user experiences built out with CloudXR is essentially, our platform could support thousands of concurrent users, so you could essentially have as many users as you want joining their own CloudXR experience. And so what that would essentially be is, imagine you have an Unreal application, a Unity application. Each of those users gets their own direct stream to a Unity application, but then the multiplayer experience would be essentially brokered the way it would be in any sort of multiplayer experience. All of those discrete Unity applications would talk to a coordinated multiplayer server to exchange whatever sort of multiplayer or multi-user information they want, which is typically be something like positional information. In the browser world, we do support a concept we call concurrent or synchronous collaboration, which is where multiple users can actually share the same stream. but given the headset positional information is going to be unique for every individual wearing a headset, that mental model doesn't work in a VR context. And so you have to basically give each VR user their own stream source and then coordinate multiplayer of those stream sources on the back end. We haven't, so we've talked to customers who are interested in doing this. On the VR side, we've had many customers who've done this on the pixel streaming and browser side. So we know it's a very, it's a well understood problem and it's a very solvable problem. There's things like Epic Online Services to support the multiplayer elements if you're building on Unreal. There's a lot of ways of solving that problem. Renee asks, is Unreal 5 supported? So right now in the closed beta, we are only working with Unity. Unity support is currently across the board. We are actively, and when I say actively, I mean like the team is today and this week focusing on Unreal development. And so our intention is to support Unreal 5 as well. It will be in accordance with our current engine support guidelines, which is to say we'll support the latest version of Unreal Engine plus the latest or the last version in the 4.x line. So it'd be 4.27 and 5.3, or if it drops in short order, 5.4. Renee also asks, is the 50 and 100 megabit needed for a download and upload? So it is very much an asymmetric link. So it's essentially the download is much more intensive. The upload piece is drastically less bandwidth intensive. You can get by with realistically, I don't know for certain, but I would assume it's going to be around 10 to 15 megabits because all you're sending is positional information, head tracking information, controller information back to the application. It's really that really very data dense video stream that is coming down from the server that demands the high network bandwidth there. Let's see here.
The chat.
I'm sorry, Candy?
There's some questions in the chat. So from Eric, just read it out to you. Can you host 8K 360 3D video streaming live shot with a VR camera and on demand? Can you stream it as a direct URL to play from our proprietary player in a browser on a website? I'll let you answer that first, and then there's a question 2 and a question 3 follow up.
All right, can you host 8K 360?
I mean,
yeah. So I'm sorry, Kevin, you were going to.
I was just going to say, I mean, 8K 360 video. We've never done it before. Not to say that it's not impossible. I think the bandwidth requirements definitely go up when we're talking about 8K, and if that's a binocular kind of 8K video stream, that might be up to like 200 megabits per second, 250 megabits per second for a reliable, consistent stream there. In terms of streaming it to a proprietary player, it might be best for us to just talk offline on this, Eric, to get more of your ideas as to what your problem is that you're trying to solve there, or what you're trying to integrate into an existing system. I mean, it's not what our product strictly does today, but I mean, Chris, you might have something to add on that.
No, I think that's a conversation I think we would rather have sort of more organically because we want to understand these use cases. I think the thing that I want to clarify though is that in question 1 you're saying can you host 8K 360 live video streaming? The expectation if you're working with CloudXR is that you are building a stream source that is OpenXR compatible. So that is either an Unreal application that is with the OpenXR with the CloudXR plugin, the Unity application with the CloudXR plugin, or a native application that talks the OpenXR compatible API. And so if you have this 8K 360 video in one of those valid formats, then CloudXR will work for you. But if it's just sort of video streaming as sort of raw video, then that might not be necessarily the best fit. And then question 2 is XR also running with Babylon supported also? Kevin, I think Babylon is a WebXR tech.
Yeah,
Is
that's
that something you
correct,
can speak
Chris.
to?
My understanding is it's WebXR, which is again a little bit of a different domain from what we're talking about today. But love to get more of your ideas there, Eric.
And then question 3 is, what is the round trip latency? So I can say that that sort of goes back to the previous question, which was latency in the demo that we saw would have been probably about 25-ish milliseconds. And then within our platform, we really strive to make sure that we're always routing you to basically infrastructure that is going to be less than 50 milliseconds away. And the way we do this is by trying to maintain a very broad infrastructure footprint. So this is AWS, through a combination of both the regional data centers and local zones. We have the ability to really put infrastructure anywhere, and that allows us to and that allows us to sort of solve for that latency problem. And I think
that's it.
that is all the questions. All right.
Actually, sorry, Chris, there was one more that just wasn't covered. Renee had also asked, does the stream also have audio capabilities as well? And just to answer that question, yes. So anything that you have running in your application for audio is also sent to the headset.
Awesome. Thanks, Terry. I missed that one.
Yeah.
No problem.
All right. I think that's it, Chandy. Yeah. You want to close this out?
Yeah, if there's any further questions, I don't think so. Like Chris said, there's a QR code here that you can scan, which will take you to a page where you can register to get notified when we are out of closed beta. Or as an alternative, you can email sales@pureweb.com to express interest. Thank you everyone for joining us today. Like I said, this was recorded and we will be sharing that recording, so you can go back to reference anything you might have missed. Yeah, that's it for today. Thank you. Thanks, everyone.
Thanks very much, everyone. Goodbye.
Thanks, everyone.
Thanks,
Bye-bye.
everyone.